All right, I'm going to be demonstrating WebWork 10 problem number 16, which is an initial value problem with a mass and a spring system. So we're given in the problem that there's a mass attached to a spring and the mass weighs 4 pounds. So our first step is going to be to convert that weight measurement into a mass measurement. So weight's really equal to force, which in this case is equal to mass times gravity, because this is a vertical spring system. So that means that 4 is equal to m times 32 with these units. So m is equal to 1/8 slugs. So we're also given that the damping constant is equal to the instantaneous velocity at any point. So that means beta equals 1. And we're given that the spring constant equals 2 pounds per feet. So we can set up our differential equation, 1/8 x double prime plus 1 x prime plus 2x equals 0 because there's no force being applied on this system. So we can simplify this by multiplying by 8. So it's x double prime plus 8x prime plus 16x equals 0. So now we can solve. We'll use r squared plus 8r plus 16 equals 0. Now this one is pretty easy to factor, so r plus 4 equals 0. So this means we have a repeated root. So our general solution is going to be c1 e to the negative 4t plus c2t e to the negative 4t. So now we have to solve for the initial conditions that we're given. So the problem gives us that the weight is going to, or the mass is going to start off 1 foot higher than the equilibrium spot. So that means that our x value is -1 foot. And it also gives us that our velocity at the start is equal to 8 feet per second. So we can solve for C1 by substituting in -1 equals C1 e to the negative 4t is going to go to e to 0, which is going to be equal to 1. And then this term is going to cancel out because of the t in there. So that means that c is equal to -1. So now we're going to find the derivative of yc, and that's going to let us find the value of c2. So I realize in this I changed variables, so this actually is going to be an x. I have been doing that a lot. It's an easy mistake to make. So x is going to be the function that tells us our position of the mass at time t. So since we're given that our initial velocity is 8, go ahead and substitute that in, and then t is going to equal 0. So this is going to go to -4 c1, and this is going to go to 0 because of the t. Then our final term is going to go to plus C2. So that means that 8 plus 4 C1 is equal to C2. So since we know C1, so that's 8 plus 4 negative 1 equals C2, or 8 minus 4 equals C2. So that means that we can write our solved solution with the initial values taken into account. It's going to be x equals negative 1 e to the negative 4t plus 4t e to the negative 4t. So now that we have that, we can actually solve for what the problem is asking. So the first thing the problem asks for is the time at which the mass passes through the equilibrium position, because we know it did not start there, it started above there. So what we'll do in this case is we'll set our solution equal to 0 for x. So 0 equals negative 1 e to the negative 4t plus 4t e to the negative 4t. So we can't solve it with these with the e to the negative 4t terms, because that's never going to go to 0. So we can factor that out at the beginning, and then we're left with 4t minus 1. So 4t minus 1 equals 0 at 0.25 seconds. So that's the time that the mass is going to pass through the equilibrium position. Now the next part asks the time at which the mass attains its extreme displacement from the equilibrium position, or the farthest point it's going to go away from that. So what we will do to find this is we'll take the velocity function, or the derivative of the x function. So that will be, we already solved it. So now that we have more values, we can go in and substitute them. It's going to be okay. So the extreme displacement is going to be when the velocity equals 0, because that's going to be the moment at which it's turning and moving back up. It's not going to move any farther down. So the velocity at that point is going to be 0. So we'll set this equal to 0. And well, so we can just move this right over. Equals 8t. Oh, so messed up here. So this C2 is 4. So 4 times 4 equals 16, not 8. So it's an easy fix. So right away we can get rid of the e to the negative 4t because it's on both sides, and we're left with 16t equals 8. So t is equal to 1/2 seconds. So the last part of the problem asks us to solve for what the position actually is, that extreme displacement at t equals 0.5 seconds. So at this point, we're just going to plug this t value into the x function, which I believe was x equals so that's going to be pull this out and we get 2 minus 1. So that would mean that x is equal to e to the negative 2, or around 0.135335 feet. And you can just estimate that on a calculator. All right, let me know if you have any questions in the comments. Thanks.